Welcome to the XtextCasts. In this episode we will talk about ModelInferrer and how it's used in a scripting language. This is one of the 7 languages for JVM. You can also refer to the episode 8 for the brief presentation of all those languages. Let's start with a simple Xtext project. And then run the workflow. And I say yes here to download ModelInferrer parser. After everything generated and compiled, let's take a look what we have. We have a grammar that extends the terminal's grammar, and it has a model with a list of greetings, and each greeting has a name. Also we have a generator that we can implement, and with this generator we can generate any kind of artifacts, for example SQL or XML or Java. This grammar doesn't make use of the X-space now, so let's change it. And in order to activate the X-space we have to extend our grammar from the X-space grammar. And then run the generator again. And the main features of the X-space are that we can use extend-like expressions in our language, and we can use ModelInferrer to generate Java that is tightly integrated with an Eclipse JDT. Let's take a look of the ModelInferrer that get generated. And this is an example implementation for our example model. So we have model with the greetings, and here we take model, and for the model we generate a class with this static name, and we generate for each greeting a method with the name hello and then the name of the greeting. This method has a return type of string, and the body is just return the string hello and then greeting name. At the first glance, this is more verbose compared to the old way, where we use the standard extend reach strings to generate entire Java class. But it's designed to generate complex Java logic, and it also binds every Java element to the Eclipse JDT elements, so the JDT tooling works correctly, for example searches or refactoring. And you can also enable debugging, and if you want to know how to do it, you can refer to the episode 5. Now let's run the second Eclipse instance in the debug mode. In the second Eclipse instance, let's create a new Java project. And let's call it test. And here let's create a file, and we call it test my.dsl. And here I say yes to add Xtext nature to our project. So if we here add some greetings and save the file, we see that our class gets generated. And in order to see it a little bit better, let's add this folder as source folder, and so we can just open our class. And here we can see the expected class with 2 methods for each greeting we defined. Back to our main Eclipse instance, let's take a look how the ModelInferrer works. And in the runtime model, I go to the outline and I press the Ctrl-O twice to show the inherited members. And I search for the bindIGenerator method. And here we can see which generator gets used. And this is of course an X-space generator. And let's take a look of it. And here we go to the doGenerate method. And this is a single method in this class that implements this iGenerator interface. And let's place a breakpoint here. Now let's go to our ModelInferrer and place a couple more breakpoints. One on the first line, then on the line where we add members and one on the line where we define bodies. Now I change to our second Eclipse instance and say clean. And this is our first breakpoint hit. In the ModelInferrer we define our class. Next, the methods get defined, and then the generator get called. And if we take a look of the contents, then we will see actually two models in the contents. And one is our domain model, and second is the Java model. So our inferrer is some kind mapper between domain model and Java model. And if we take a look of this Java model, we will see the configuration of our class with the final false and package name and so on. And members, we have 3 members. This is 2 operations and 1 constructor. And operation is has a simple name and is non-final and defines no exceptions and so on. Now if we proceed with the code generation, the ModelInferrer body closure get called, and here we define the content of each body for the methods we modeled. And now we are done. Next, let's take a look of the scripting language, and this is the most simple language from the 7 languages for the JVM. And here I already imported those 4 projects into my workspace, and I can run my second Eclipse instance. And within the second Eclipse instance I create a file and I call it print.script. And I define a variable a and b and print the sum of the a and b. And if you have such errors in your Xbase expressions, this means you miss Xtext libraries within your class path. So let's add it. And now our script gets compiled, and we can see the source code. And this is a simple class named after our script class with a single main method and our code within the main method. Let's see how scripting language is implemented. It starts with a script rule that contains list of expressions and list of imports, and import is aligned with a import keyword and then the qualified name with a wildcard, optional, assigned to this magic attribute imported namespace that actually imports a namespace into the scope, and the list of expressions that references the Xbase type, and this Xbase inside block type is simply everything you can write inside curly braces. And if we open the declaration, we will see that how this rule used within Xbase. Now let's take a look of the ModelInferrer. And this is a very short ModelInferrer. First we get the URI of the resource, trim the file extension and take the last segment. So the class name will be the name of the file without extension. We create this class and add a member. This is a main method with a return type void and a single parameter args with an type array of strings. And we set it to static, and then we assign our script to body. And why we actually can do this? This is because our script is actually inheriting from the xblock expression. We define here script in curly braces, so this the script class will be created. And since the xblock expression must be returned from this rule, the script inherits xblock expression, and if we just open our script interface, we see that it extends XBlock expression, but it only defines get imports, so the imports list, and no expressions list. And this is because the expression list is already defined within XBlock expression. And this allows us to assign the entire script to the body, and the body converts the list of expressions to the content of the main method. As you could see, the ModelInferrer is a powerful generation concept of the XSpace. It may look a little bit too complicated at the first glance, but once mastered, it offers a lot of advanced features that would be really hard to implement using the old extend rich string approach. Just think, for example, of the DSL debugger that works nearly out of the box. Check the episode 5 for more details on that. Thank you for watching XtextCasts. Go to the XtextCasts.org to get show notes, discussions and more episodes.